Now let's look at these two concepts called concentration and loading. So a lot of our parameters are given in terms of concentration. Solids content 300 milligram per liter, BOD 250 milligram per liter, and so on. But when we convert it to loading, this is in kilograms per day. That's more meaningful because that is the load that your sewage treatment plant is going to handle, right? So how do you do that? We take the concentration and multiply by the flow, and of course with adjustment of the units involved, and you get the thing. So when you have a bigger volume but lower concentration, it can result in equivalent large loading that comes in, right? So this is how it looks like for typical sewage. Flow, solids content, BOD, and nitrogen based on this. Now let's look at sludge. Supposing I add the same septage from the same 1 lakh population, which is only 56 cubic meters, but the concentration of parameters are very much higher. Actually, I have not assumed very high figures. Some of these figures could be much, much higher. But when you multiply this small figure by this high figure, you do not get very high figures. You still get small figures here, right, compared to this. So this is what it looks like. So flow, the small black thing up here is the additional flow due to the septage addition. Here the solids content is a small black proportion. It is now already becoming a little significant compared to the flow, BOD and nitrogen. So this is what happens on a daily basis. So this is the daily load we're talking about. But that's not enough. We have to look at the flow variation over the day. Now this is the solids load variation. Just like flow varies over the day, the solids load also varies based on the flow, right? So this is how it looks like. Now what will happen when we add the fecal sludge, which has very high solids, during certain hours of the day? So there's a marked increase here because this is where the sludge is being added during working hours of 9 to 5, and you find that the increase is very substantial. And this same kind of typical increase can be seen for BOD and total nitrogen as well. So now, how does this impact our treatment process? If your treatment process is a very long process where there's complete mixing and the retention times are very long, then this may not have that much of an impact because it evens out over the day. But when you have treatment processes like SBR, for example, where you might have a shorter duration of process, then that shorter duration could fall within this peak, and that will have a bigger impact, right? So what can we do? We can do equalization, flow equalization. We can add the fecal sludge during the off-peak time. So these are some of the things we could do, but we need to understand really, is this a serious problem? So we need to analyze it this way to see, rather than just saying I'm adding 0.5%, but when are you adding? How is the characteristics and so on.